Hey, good morning, everyone. Today we're going to be working on starting the depth gauge activity. And the depth gauge activity is listed in metric units. And if we take a look here, that's listed in millimeters. All right, so we're going to change our workspace here to reflect those units. So I've created a new document. I've named it 15-8 depth gauge. And we're going to go to the hamburger in the top left, and we are going to come down to workspace units. So right now, our default unit is the inch. We can change to either centimeters or millimeters. We're going to select millimeters because that's what the drawing is already in. And then the default being to the nearest thousandth is going to be fine. So we can click the checkbox, okay? And now, as we go in and we start to create a sketch and we start to create like a line or a box or anything else that we have, when we put in like a number like 20, what we're saying here is that it's 20 millimeters long, all right? And again, that's just going to go back to these dimensions here. Okay. Let's take a couple moments here to take a look at this drawing to get some more information about what's happening here. Ultimately, this is a pretty small little part, but it's got a lot going on, including this rod that goes through and the screw at the bottom. And essentially, like it's called the depth gauge, we can put this base someplace flat, and then we can unscrew this thumb screw a little bit and push the rod down till it touches the bottom of whatever it might be. Sometimes you might use this to measure like the depth of a cylinder in an engine. And then you can tighten the screw back up again, and then you can measure between the bottom of the base and the bottom of the rod to determine how deep that feature was. Okay, so inside of the handle, there's actually a hole that goes through this thing that allows the rod to pass into it. Okay, and that gets press fit, which means it's a friction fit into this base, which has the threaded hole that's going to accept, or here's our base right here, the threaded hole that is going to accept our little screw at the top. Okay, so again, this piece here and this piece here, this is like a side view of this piece. So we can see that this hole in the top is 8 millimeters in diameter. It goes down 9 millimeters. And then there's a 3 millimeter ream, which really means a 3 millimeter hole. When we ream a hole, it's a little bit more accurate than just drilling one, but we're going to drill one in CAD. We also can take a look at the handle itself, which again is this part here, and this is a section as we cut straight down through the middle of the handle. But it also mentions that there's a medium knurl around the outside, which is like a texture. And we're probably not going to be modeling the knurling into our project. There's also a little bit of knurling on like the edge of the screw. And the screw that we have here is a really small screw. And similar to our 316, this is a metric threaded screw. So it is an M5, which means it has a 5 millimeter diameter and by 0.08, which means that each thread is 0.08 inches away, or I'm sorry, 0.08 millimeters away from the next thread. Okay, and again, we have an M5 by 0.08 for the screw and an M5 by 0.08 for the hole that it is associated with. So I'm trying to look around here and think about other things that you guys might have some questions about, but as of right now, I think that that's most of it. This is going to be a revolve move, most likely, maybe not, but most likely, especially with the interior being threaded out and stuff, or a hole in the middle. Probably another revolve move up here with the screw. This is definitely an extrude move down at the bottom, and then we'll get these things assembled. So we have one part, two parts, three parts, and the rod, which the only place where they tell us about the rod is over here, which that rod's dimensions are right there. So ultimately, we're going to have 4 parts here for this total assembly, and then it's going to get put together. We're also going to make it so that our rod can move up and down so that the bottom of the rod at its max will be flush with the bottom or its minimum. And then at its maximum, the top of the rod is going to be flush with the top of the handle. So we're going to see some movement in our assembly later on. All right. So if you guys have any questions, feel free to reach out to me and we're going to go from there.